a second. For those of you who haven't been to one of my webinars before, I'm Sarah Vaya. I'm a professor at University of Maryland. And I've been giving these webinars every summer since 2020. It's been a terrific experience for me, and I appreciate everyone coming. This slide might look a little harsh, but I want to put it into a context. This summer has been one of really big climate change impacts. We've choked here on the East Coast, we've choked on wildfire smoke, and I had to wear my N95 mask outside to go for a walk. We've had huge floods in Vermont. We've had a little taste of the extreme heat that the people out in Texas and the Southwest have been suffering from. And as I was preparing this, this webinar, I saw this article in Climate Nexus, July 31st, that says the era of global boiling has arrived. Europe is like a blowtorch. US parks are an oven. Atlantic is like a hot tub during the hottest month ever. This July, residents of planet Earth experienced the hottest July of at least the last 120,000 years. And this is climate change in action. So as we were experiencing this, and I was thinking about these really terrible impacts that let us know that we are in the middle of this process and it is going to get a lot worse. I was reading about some of these dubious climate solutions and greenwashing by corporations. And one morning before breakfast, I just kind of had it. And I made this little graphic. No more time to waste on lies. I was really angry. And, you know, anger is important for motivation, but you can't just stay angry all the time. That's not very healthy. And anger by itself isn't very productive. So I realized that one way we can fight back is to be sure we know what these lies are, what this greenwashing is that corporations are doing, what's going on, who's supporting it. And when we know what is going on, then we can teach other people and we can figure out what to do about it. So that's where I'm starting from. Okay, here's an outline, because like last time, I'll be talking about quite a few different things. First, what's net zero and how do we get there? I want to review various climate solutions, real solutions, fake solutions, and sort of one maybe solution. I want to discuss what I think of as some of the main problem strategies. I can't talk about everything, but I've picked these four: carbon capture and storage, biomass to energy or ethanol with carbon capture and storage. So CCS stands for carbon capture and storage, direct air capture with storage, and hydrogen, methane-based hydrogen with storage, which is the sort of the better of the two options currently available, or green hydrogen. I'll tell you what all those things are. I'll just quickly say one of my main conclusions: instead of requiring emissions cuts, we're funding unproven and risky strategies. So I'll wind up with a little summary of what I think we can do about this. This is a picture of a cartoon, really, which is all people have because this is pretty much unproven, of how carbon is injected into formations way below the Earth, and we'll go into that in detail. First, what's net zero? Net zero is, I think I referred to it in the summary, the blissful state where the residual emissions we have not been able to get rid of, are balanced by carbon removal. The idea of getting to net zero, and this is a little cartoon from the National Academy of Sciences, it just gives you sort of the general gist of it. This would only give us, this would only allow us to limit global temperature increase to 2 degrees. But the idea is, you know, here we are. If we do business as usual, we're going to keep increasing emissions, and it's not going to be a good scene. So we have to reduce our emissions along this red line. And this cartoon does not reach net zero until 2090. We have to be there by 2050. We now know that. So we have to reduce it faster. But the idea here is, in this picture, at 2090, the remaining emissions that have not yet been, eliminated are balanced by what's called negative emissions, that carbon removal from the atmosphere. So we know there's too much carbon dioxide in the atmosphere. We need to take some out of there and limit our current emissions. So at net zero, the residual emissions are balanced by carbon removal. The sort of plan on how to get there, the general idea is that we need to reduce all possible emissions. Now, this is the first problem. We need to reduce everything we possibly can, not just the emissions we feel like reducing, okay? Either as individuals, communities, corporations, whatever. So it's not like, let's pick and choose and just get rid of the ones we, that won't bother us. Let's get rid of everything we possibly can, okay? And then remove, so we have to be building up the negative emissions as we're doing this. Remove carbon from the atmosphere to cancel out the remaining emissions. So the National Academy of Sciences describes these remaining emissions as hard sectors that are hard to decarbonize or to basically get off fossil fuels. And those hard to decarbonize sectors are air travel, shipping, steel, and cement. And they also add a couple of sectors that they describe as disruptive to ask for reduced emissions. And these are diet and agriculture. So these first sectors, assuming that there are no new ideas to decarbonize these sectors, we have to do something with them. Okay, so we need to probably cancel out those emissions. But this assumes that if we still have these left over at 2050, it assumes there's really not very much public or political will for change. And I think this is an area we need to work on considerably. I should just mention, I forgot the housekeeping. You can, if you have a problem, Anne Strozik is helping me again this time. If you have a problem, a technical problem, you can put that in the chat and she'll help you. If you have a question or a resource you'd like to share, you can put those in the Q&A, and then I'll answer questions at the end. So sorry, I forgot about that. Okay, now let's talk about climate solutions. I want to start out with real climate solutions that we know will work. First, reduce greenhouse gas emissions. We need to reduce carbon dioxide by stopping burning. We need to stop burning fossil fuels and wood. We need to stop using ethanol and gas. Methane, stop using and exporting fossil gas. When I say fossil gas, I mean methane gas, okay? I don't want to say natural gas, which is a phrase that's been promoted by the gas industry because it sounds sort of like, this is natural, it's okay, it's good. It's fossil gas, it's a fossil fuel. We need to cap the zillions of abandoned wells that are out there in, oil and gas country. We need to stop fracking, okay? I don't have that on here, but we need to, if we stop fracking, we stop using them, we don't have gas pipelines that are leaking. We need to reduce food and yard waste, which cause methane emissions in landfills, improve our landfills to sort of put a lid on that, and reduce meat and dairy. Those are sources of methane emissions. Nitrous oxide, methane and nitrous oxide are greenhouse gases that are more potent than carbon dioxide. Methane's a little bit more potent. Nitrous oxide is a lot more potent. And nitrous oxide primarily comes from using synthetic nitrogen fertilizer, especially too much synthetic nitrogen fertilizer. So that's the reduce emissions side. These are things we know will work to slow down and halt climate change. Second thing, remove carbon dioxide from the atmosphere. Well, the big winner in removing carbon dioxide from the atmosphere are plants. These guys suck carbon dioxide out of the atmosphere. Woody plants, like in forests, store a lot of carbon in the wood, and other non-woody plants store a lot of carbon underground. So to remove carbon from the atmosphere using plants, we need to dramatically reduce deforestation. We're cutting down forests all over the place, in the tropics, in the US, everywhere some developer wants to build a development, they cut down the forest. We need to replant trees where they once were. Okay, that's afforestation. The phrase where they once were is important because we don't want to plant trees in prairies where they never were, because that's going to be a problem. We need to improve agriculture to boost soil health and store carbon. So those are bona fide climate solutions. Okay, now here's something that would totally work, but would be very hard to implement. Want to stop emissions fast? End the subsidies to fossil fuel companies, billions of dollars that they receive every year, and even more money that taxpayers spend to overcome the impacts of pollution, et cetera, and climate change caused by fossil fuels. I do not know, well, I know the fossil fuel companies love these and, they keep them coming, but it's totally counterproductive. We could put a tax on luxury goods and private jets. So the top, 1 or 1.5% could be paying a little bit more. I find it hard to believe they would miss it, but they evidently feel they'll miss it a lot. So this is not going to happen. Okay, let's move to the fake solutions. Carbon capture and storage, biomass to energy with carbon capture and storage, direct air capture with storage, and hydrogen. The maybe solution is green hydrogen. So there are three. Hydrogen, it doesn't really come in colors, but the manufacturing process, production process, those are given colors. Gray and blue hydrogen are essentially dirty, made with natural gas. Green hydrogen is made using renewable energy. And so that might have a place as a useful climate solution. Then I want to just mention the don't go there solutions. I am absolutely opposed to any form of geoengineering because being a scientist myself, I can tell you scientists focus on, their problem, and they often don't see the, wider implications of their solution. And I really feel bad about and very scared about things like, let's put aerosols up in the sky to block the sun. My opinion, don't go there. Okay, so we're going to start out with these fake solutions, carbon capture and storage. And I want to talk in detail about carbon capture and storage, which, isn't generating itself any energy, but it is involved in so many of these solutions that it's important to understand how it works. In my opinion, carbon capture and storage is nothing more than corporate greenwashing posing as a solution. So here's how it works. And here's a diagram from the National Academy, one of the National Academy reports. So, let's say there's some sort of manufacturing facility like an ethanol plant or a fertilizer plant or a power plant or something, and it is emitting carbon dioxide and a lot of other stuff into the air, okay? With carbon capture and storage, there's technology that uses chemicals and a lot of energy to pull the carbon dioxide out of whatever is coming out of the smokestack, okay? Only the carbon dioxide. And remember, it takes a lot of energy to do that. So then the carbon dioxide is liquefied, transported by pipeline, sometimes thousands of miles away. And then it's buried, by drilling down and injecting it into a variety of different places. The possible places are deep saline aquifers, depleted oil, gas reservoirs, salt beds or caverns, unminable coal beds. I'll talk about this a little bit more on the next slide. So this capture process catches part of the emissions, not all. Only part, from burning fossil fuels or wood for electricity, from fermenting corn or other biomass, from making synthetic nitrogen fertilizer, which requires really high temperatures achieved by burning fossil gas, or making hydrogen, gray and blue hydrogen with fossil gas. Here is the one thing I want you to remember about carbon capture and storage. It does not remove any carbon dioxide from the atmosphere. It just allows a little bit less to go into the atmosphere when we're burning fossil fuels or doing something else we probably shouldn't be doing, okay? So because no carbon dioxide is removed from the atmosphere, it is not a negative emission, and carbon capture and storage cannot help us reach net zero. End of story. You would not know that by reading most of what is coming out of the, from the fossil fuel companies. My understanding and my conclusion from all the stuff I've read is that carbon capture and storage allows fossil fuel companies to continue to sell their climate wrecking products, and this is what has made me really angry recently, and get billions of dollars in incentives from the Infrastructure Act and the Inflation Reduction Act, from last year. They're getting billions of dollars in incentives while posing as part of the solution. So they present this public face of how they are really doing a lot to solve climate change. But really, they're not taking anything out of the atmosphere, nothing negative. They're just putting a little less in, and it costs billions of dollars. So this is the biggest greenwash of everything that I'll talk about today: carbon capture and storage. Okay, there's a bunch of problems with carbon capture and storage. Let's start with capture. First, there are very few examples of successful carbon dioxide capture, and these are very small, okay? These are very small. Many projects have been planned. This is a graph, carbon dioxide sequestered annually over various years. Here are projects that have actually been built and how much carbon has been captured. And here are projects that have been planned, okay? Proposed but not implemented. What happens is these companies propose these projects and then they realize, whoa, this is going to be hard and it's going to cost a lot of money and it might not even work. So they don't go through with it. In the US, there are several ethanol plants that have a capture rate of 11% of what comes out of the exhaust, and a big fertilizer plant run by Archer Daniels Midland. And they capture a part of the carbon dioxide. I don't know exactly how much. There was one attempt to put carbon capture and storage on a coal-fired power plant, the Petronova plant, if you ever want to read about this. They spent over $1 billion. This plant was only, the carbon capture was only active for 3 years. And of that 3 years, the capture was offline for 1 year, okay? And they used the captured carbon dioxide liquefied to in what they call enhanced oil recovery. That means they used it to bring out more oil from oil fields that were not, there wasn't enough pressure to push the oil up by itself. Okay, so they're capturing this carbon supposedly as a climate solution to bring up more oil. So when the price of oil dropped, NRG, who owns the Petronova plant, abandoned it because it was no longer cost effective. What the incentives are doing is making it cost effective. Okay, basically we're paying them to do this. Right now, globally, there are 27 carbon capture and storage plants and they're capturing different things. Their typical capture rates are between 40 and 54%. Although they claim 90% capture, they're not capturing anything near that. And in 2020, let me just tell you, give you an idea of the magnitude of this. It is at such a small scale that it is really barely worth thinking about as a solution. In 2020, 37 million tons of carbon dioxide were captured. This is less than 1%, 1/10 of 1% of global carbon emissions in 2020. How big of a difference is that going to make? So, there are a few more problems with capture. The next issue is that carbon capture and storage captures none of the other air pollutants that are emitted we know from coal and gas-fired power plants. Lots of other stuff comes out, and also from the fertilizer, et cetera, the other plants. Volatile organic compounds, benzenes, other hazardous compounds. 85 different toxins come out of a coal-fired power plant. Heavy metals, PM 2.5, which you all know about after breathing that fire smoke a few weeks ago. This stuff comes out of the smokestacks, but it's not captured by carbon capture and storage. So that air pollution is still going out there, harming everyone's health. Also, carbon capture and storage does not capture any upstream emissions. That is anything associated with the product being made or the power being made that occurs before the actual plant. So, for example, it doesn't capture emissions or pollution from conversion of forest to cornfields, which has happened because of the renewable fuel standard. Chemical use for ethanol, a lot of chemicals come out of the stack when ethanol is made. Any emissions or pollution coming from mining, drilling, fracking, transporting, and storing fossil fuels. You know, there's a world of problem there. It does not capture any of the emissions from the power and the chemicals that you need to capture the CO2, the capture equipment itself, okay? It captures some CO2, but you have to spend energy to get that to work, okay? No, none of those emissions. Usually it's gas-fired. None of those emissions are captured. These sources of greenhouse gases can greatly exceed the captured CO2. And I just said that it doesn't grab the emissions from the power required for the capture. So this article, oh, I don't have the date on here, but this peer-reviewed article queried a number of so-called experts who gave assessments of essentially how much they thought was being captured in these different settings, power plants or industrial. Power plants, maybe around 60%, but a lot of variability. And industrial, around 40%. So a lot of carbon dioxide is still coming out from the plants themselves, from the supply chain to the plants, if you will. And so this idea that, oh, we're going to happily capture all this carbon, we can continue to do these things, and it won't be a problem because we'll just capture the carbon, and then we'll tuck it away underground where we don't have to think about it anymore. Okay, so there's a second part of problems with carbon capture and storage: transport. The carbon dioxide is transported in pipelines in a liquefied form under pressure. There are 2.6 million miles of oil and gas pipeline, just to give you an idea. And when we have an oil leak, you know, the oil comes out, it doesn't explode out, it just comes out, okay? But more than this is at least some things I've read suggest that more than 2.6 million miles is going to be needed to transport enough carbon dioxide to make a difference in, you know, climate change. Oil and gas pipelines can't be reused for carbon dioxide, although I've read reports from reputable people who suggest that they can. Of course, the oil and gas industry wants to reuse these pipelines, but liquid carbon dioxide is highly corrosive if there's even a trace of water or hydrogen sulfide. Both of these are very common in the carbon dioxide captured in CCS. Liquid carbon dioxide is under pressure. When a pipeline breaks or ruptures, it's violent. There's an explosion of carbon dioxide. This is a picture taken on someone's cell phone in Mississippi during a rupture of a carbon dioxide pipeline there. And I'm going to tell you more about that in the next slide. But you can see it shooting up into the sky, you know, very high, and made a huge noise. And by the way, this is frozen, okay? It's frozen, basically, and then it turns right to gas. Escaping frozen CO2 quickly vaporizes into asphyxiating carbon dioxide gas. Now, you know that when you breathe, you take in oxygen and you breathe out carbon dioxide. You cannot breathe in carbon dioxide, okay, because you will basically smother. It's asphyxiating. And so when you have a carbon dioxide pipeline break and it spews out all this carbon dioxide, the area around the breakage, a large area around the breakage, is filled with essentially asphyxiating gas. People can't breathe. Okay, now this happened in Mississippi in 2020. Here's a picture. The pipeline broke. All this white stuff is essentially dry ice. It's frozen carbon dioxide. I don't know how these guys are standing there. Maybe they have masks on or something. But what happened was people were driving down the road near this. They heard a gigantic bang. That one person saw that, you know, a big amount of carbon dioxide coming out. They smelled rotten eggs, which indicated that hydrogen sulfide was mixed in with the carbon dioxide. 49 people were hospitalized, but they went to the hospitals and the hospitals had no idea what to do. They never even heard of carbon dioxide, breathing carbon dioxide. So there's a lot of delay in getting people the attention they needed. Several now have permanent respiratory damage. 3 of the 49 are unable to return to work. This occurred in a majority Black community. There was very little publicity about it. And really, it was sort of swept under the rug. The pipeline company came around and offered residents $5,000, which is beyond insulting. This company, the pipeline company, went bankrupt, but they recovered and now they're back and they're proposing to use the same pipeline again for carbon dioxide. And again, they're going to send it to a depleted oil field and use it to recover additional oil. Okay, storage. So let's imagine we've got the carbon dioxide to the place where we're going to store it. It's captured by the power plant. It's transported in liquid form for thousands of miles. I read this little list, although this list doesn't have the last one. So there's deep saline aquifers, that's salt water that's sort of confined in by rock. They're freshwater aquifers and they're saline aquifers. Depleted oil and gas reservoirs, salt beds or caverns, unminable coal beds, and geological formations of basalt or periodite. These are really the best because they interact with the carbon dioxide and turn it essentially into rock. That doesn't happen in these other places. So how many of these storage methods have been used at scale? That means in more than sort of an experimental way. 1, depleted oil and gas reservoirs. This is the big favorite. 95% of the carbon dioxide captured to date in carbon capture and storage has been used in enhanced oil recovery, okay? And I just have to ask, this is a climate solution? How can anyone who does this say with a straight face that using that carbon dioxide to bring up more oil is a climate solution? I'm sorry, it isn't. And although they say the carbon dioxide is down there forever, I've read many, many papers and articles that say, especially in oil fields, the carbon dioxide is likely to leak right back to the surface through abandoned wells. There are as many as 10 wells per square mile in a lot of these oil areas. And although this nice picture basically shows, here's the production well, that's where they're getting the oil from. And here's the injection well. So they inject down here into this rock formation or where whatever the oil is in, and the extra pressure pushes up the oil, okay, like this. That all looks really handy and great, except if there's 10 other, pipes going to the surface nearby, because then you increase the pressure and, the carbon dioxide just comes out those other pipes. That seems fairly obvious to me, but, they say, well, I mean, this is why I'm explaining this to you. I feel like if more people know that this strategy is really like the emperor has no clothes, then maybe they won't get away with it quite so frequently. Anyway, so this carbon dioxide, I think, is probably going to wind up back in the atmosphere. Okay, storage. When you inject liquid CO2 at high pressure, it can lead to, quote, seismic activity. That means earthquakes. And once you have, below ground earthquakes, you get rupturing of the rock that supposedly is holding the carbon dioxide in. And the paper I read, which was in PNAS here, suggested that particularly in inland sites, like where they're stashing the carbon dioxide from ethanol production, the rock formations are kind of brittle, and they show this map in there with the red dots being sort of seismic areas. And here's where they're planning on putting a lot of the CO2 captured in ethanol production and fertilizer production, very close to this. And so they figure, and they're putting it down there at high pressure, right? So that creates a situation below ground, which is likely to lead to earthquakes. Now, I read at least a couple of articles where the people are saying, Well, probably, these earthquakes aren't going to be felt on the surface. And this is like, oh, well, if nobody notices them, nobody's going to, carbon dioxide doesn't have a smell. Nobody's going to notice that the carbon dioxide is just leaking right out. This really bothers me. Okay. You have to really inject it slow in these areas, but do we really think these companies are going to be that patient? That requires a lot of trust. And I feel like at my advanced age, I'm not very trusting because we've seen an awful lot of mistakes made. Underground storage areas, and the literature agrees on this. Storage areas need to be regulated and constantly monitored. There's 2 successful carbon storage areas under the Black Sea run by Norway, and they have had constant monitoring. They are, monitoring all the time. And so, they will know if something is happening, and they can see, in fact, underground see with their measurements that the plume of carbon dioxide is spreading, but so far it hasn't, found a way to come up. In contrast, the U.S. is handing regulation over to the states, chiefly Louisiana and Texas. Now, again, do we have high confidence that Louisiana and Texas are going to be spending a lot of money monitoring and worrying about what's happening with the carbon dioxide? I don't have that faith, okay? There's a great article in Inside Climate News, which is an excellent source for good information about climate change. The article basically starts out saying fossil fuel companies are advertising, how safe and permanent the storage is, but they're doing everything they can to transfer responsibility for monitoring and responsibility for fixing any long-term problem. They're transferring this liability to the states. Okay, they don't want to have to be responsible for a $1 zillion, lawsuit or repair or whatever in the future. So they're just saying, okay, we're going to take the tax incentives. We're going to make the money out of oil recovery. We're going to make the money out of the ethanol, but you have the problem of fixing it if something happens. Now, I'm a little bit tired as a taxpayer of having to hold the bag for risky behavior. Okay, so my opinion, why spend billions of tax dollars on a risky strategy that doesn't remove atmospheric CO2 and will not help us get to net zero? I can't get past this question when it comes to carbon capture and storage. Okay, now here's what Exxon Mobil and the other oil and gas companies, in the answer of why are we doing this? Because Exxon Mobil and other companies really want it. And as we all know, they are very powerful. They have a big political voice, and they pretty much get what they want. Here's what Exxon says on their website. This was really, to me, hilarious. Maddening and hilarious. Exxon says, carbon capture and storage is one of the few proven technologies that can deliver deep emissions reductions in industrial sectors. Proven. Well, I don't think it's really proven. I mean, we've only captured 37 million tons globally. That doesn't seem proven to me. Carbon capture and storage could capture more than 90% of carbon dioxide emissions. Could capture. Well, actually, it captures about 50%, 60% at best. Natural gas. Oh, here's a little plug for natural gas and a little disinformation about renewables. Natural gas with carbon capture and storage ensures a more stable and cost-effective energy supply than renewables alone. Now, if you happen to live in Texas or read the news about what's going on out there, you will have read that both during the cold snaps in the winter and during the incredibly hot periods, what energy supplies go out first? Natural gas, fossil gas. What energy supplies are providing air conditioning for Texas right now? Wind and solar. So this is, I'm sorry, a lie. Okay, so here's their picture of storage. It looks really simple when they draw it like this. Even though the National Academy drawing has sort of specifications of 1.5 miles or 1.2 miles down, they're only 4,000 feet. I think, as I recall, they're more than 5,000 feet in a mile. So here's the picture. Here's these big slabs of solid rock that are sealing the carbon into its little aquifer, and they're trying to reassure you how deep it is. It's as deep as 2 Empire State Buildings, at least that deep, okay? Here's what they say near this picture. The carbon dioxide will be pressurized to increase its density by 300 to 500 times. So a large amount of carbon dioxide can be stored in a relatively small area under huge pressure. So that doesn't make me feel reassured. Then they say a 3-tier system of technologies will monitor sites for leaks at different levels: atmosphere, near surface, and subsurface. I'm sorry, I don't believe that. That's going to cost them a ton of money. They're not going to do that. And here's what they say about storing carbon dioxide in the Gulf of Mexico. Geological formations beneath the Gulf of Mexico, where ExxonMobil plans to store emissions captured in Houston, are estimated to be large enough to safely store up to 500 billion metric tons of carbon dioxide. Remember, in 2022, 37 million tons were captured. 500 billion metric tons, or the equivalent of more than 130 years of the country's industrial and power generation emissions. So this is meant to have, give people the idea, hey, this is so safe. We've got tons of room. Let's just capture that carbon dioxide. No problem. We can continue to do whatever it is we want, burn fossil fuels, whatever. And we just it's like throwing it away, putting it in your trash can and the garbage guys come and get it. But as they, say in a little sticker that they used to have up at University of Maryland, there is no away. Okay. There is no away. And this stuff, some of it's going to come back up. Okay. Some of it's going to blow up in a pipeline. If you have millions of miles of pipeline, some of them are going to blow up and people are going to get hurt. I'll leave that to you to decide what you think. ExxonMobil is planning a huge carbon capture and storage hub at their Baytown plant. Okay. Here's the coast of Texas and Louisiana. This is from Inside Climate News. A hub of major polluters, they call it. And the size of the circle is how much carbon dioxide they're letting out in 2019. And, some of them let out a lot, but they, there aren't too many around them. Others, they maybe don't let out so much, but they're crowded. In the Houston area, there are many companies, oil refineries and other things that are sending out a lot of carbon pollution. Over here in Eastern Texas, also in Louisiana, tons of pollution. Yeah, okay. So what they're going to do with this hub, Exxon and 11 other companies are going to gather emissions from their plants near Houston, and they're going to pipe those to their Baytown plant. That's what this is, the Exxon Baytown plant. They're also going to make hydrogen there. Right now, they refine oil there. It's 3,400 acres. They do a lot of different polluting things there. Exxon claims they can remove 50 million tons of CO2 a year by 2030. This is only 30% of the emissions, okay? I ask, is this realistic when global capture in 2022 was only 37 million tons? That's all of the different, plants capturing carbon all around the world. Exxon claims they're going to nab 50 million tons each year. This is by 2030, okay, but still, it's going to take them years to build this thing. So I don't think they're going to be able to do that. And again, they're still letting 70% of the emissions out. They're going to compress the CO2 and send it to storage sites under the Gulf. Nothing on this scale has ever even been tried, okay? Exxon is like, hey, we're going to do this, no problem. It's never even been tried. So many of the carbon capture and storage trials so far have been shut down. Like they gave up on it at the coal-fired power plant because it not only didn't work, it was really expensive, et cetera. The only reason that this suggestion is even viable now is because of billions of dollars of federal incentives. As a matter of fact, under the IRA, first of all, the IRA is going to pay, I think I have this on another slide, they're going to pay $3.5 billion to build this thing. Then each year, if they can capture 50 million metric tons, Exxon and their friends are going to get $4 billion a year for 12 years. And this is all taxpayer money, okay? At the last webinar, I told you all the happy news about how Inflation Reduction Act funds were being spent to allow wind and solar facilities to be built. Yay. But an equal amount of money is being spent for this. And, well, I'm sorry, it makes me mad. Okay, summary. Carbon capture and storage is really expensive. It's going to cost $100 billion. It was something else was costing $3.5 billion, $100 billion to build, and then they're going to, all funded by taxpayers despite uncertain safety and permanence. Building carbon capture and storage, and the literature agrees on this, reduces motivation to cut emissions, both from companies, because, hey, the companies can still sell their fossil fuels, but also for people, okay? People like carbon capture because it reduces the need for them to change. Hey, they can keep, driving their gas-powered car. They can keep taking power from natural gas or whatever. They don't need to change. Oil, gas, and ag industries like it because they get a ton of money to keep selling their products. The dominance of oil and gas companies in carbon capture and storage is going to prolong the fossil fuel era because they're going to use it to capture CO2 from fossil fuels. Here's the deal. If we get to 2040, okay, that's what, 18 years, and we find that carbon capture and storage really was an empty promise. Sorry, it's too late. It'll be too late to reduce emissions by the amount we need if we wait until, we find out that this doesn't work. And this came out July 14th, just 2 weeks ago. It came out in Reuters. It was on the Reuters news wire. Countries warn against over-reliance on carbon capture tech. The EU and 17 other countries caution against carbon capture overuse. I looked at the list of countries. The US is not on it. No surprise. They say carbon dioxide cuts must be the priority, not tech fixes. And this is building up a lot of tensions about climate tech ahead of COP28, which is the annual meeting, conference of the parties to talk about climate change. And the president of COP28 is the guy who heads the Saudi Arabia oil company. Okay, I don't even get that. But there we are. So that was how you capture, transport, and store the carbon dioxide. What's the current state of atmospheric carbon removal? Remember, all the stuff I was just talking about is not taking carbon out of the atmosphere. It's just intercepting a little bit of carbon dioxide from making power and industrial processes. Here is a graph showing how much carbon is removed from the atmosphere every year. And this is in gigatons. That's 1 billion tons. Land-based carbon removal, that's forests, soil, etc., removes almost 2 billion tons of carbon dioxide a year. The other current carbon dioxide most comes from conventional methods. This little magnifying glass is focusing in on this tiny brown sliver, okay? And it expands it, and the scale you can see is totally different. This is in millions of tons, okay? This is 0, 1, 2, 3. I think this got moved around a little bit. 3 million tons. The point is, it's a fraction, teeny fraction, just that amount of all of the carbon removal, which is being done by plants. Okay, this is biomass to energy with carbon capture and storage. BECCS, I'm going to talk about that next. So that's this amount, and this scale got whacked out, but it's a little bit less than 2 million tons. I'm not going to talk about biochar. Other novel carbon dioxide removal, that's like direct air capture. I'm going to talk about that. Tiny, okay? Tiny. And that costs between $250 and $650 a ton, okay? Land-based carbon removal, stopping deforestation, planting trees where they used to be, storing carbon in the soil, it costs between $50 and $100 a ton. Now, if you're on a budget, hey, are you going to spend this or are you going to spend that? So for reference, annual global carbon emissions in 2022, again, 40.5 billion tons. This is millions of tons. Okay, now let's move on to the next strategy. Biomass to energy or ethanol, so this is electricity or ethanol, with carbon capture and storage, BECCS. This is pretty much a fake solution, okay? I mean, it might work, but it's played, I want to tell you this first, it's played a huge role in IPCC climate models, getting us to a goal of 1.5 degrees C increase, okay? So they say, oh, okay, well, we've got emissions and here they are at this point. And how do we cancel them out? Well, let's put in a ton of BECCS into the models. And yeah, okay, if you put it in there, it works, but there are some practical problems. So here's how the thing works. You grow forest or crops like switchgrass, or miscanthus, you have agricultural waste. These are plants. They have taken some carbon dioxide out of the atmosphere during photosynthesis, okay? When you cut down the forest to grind it up and burn it for power or ethanol, you lose what it would have sequestered, okay? If the trees aren't growing anymore, they can't pull carbon dioxide out of the atmosphere. And native forests are cut and replanted with the fastest growing trees like pines, which might, probably aren't even native, planted in a monoculture, not replacing this forest. This takes energy. They've got to cut down the forest. They need to chop it up and, put in a truck, et cetera. Growing crops for BECCS, like switchgrass and miscanthus or something else, uses fertilizer, pesticides, energy, and water. In fact, when crops are not grown for food, when they're grown for, making power or ethanol, you can really put a lot of pesticides on them because nobody's going to eat them. Agricultural waste has been suggested as another feedstock. Some of that is going to decompose, so you get uncaptured carbon dioxide from that. You also get uncaptured carbon dioxide from this equipment. You get uncaptured carbon dioxide from the energy that is used to grind the stuff up. So a lot of uncaptured carbon dioxide here. Then you have to process and transport it for further processing. This takes more energy. So you send this stuff to the biomass power station. Some of it is turned into electricity. Some of it is turned into ethanol. Some of the carbon is captured, okay? That also takes energy, right? The carbon capture machinery takes a lot of energy. So you get this ethanol production. And I have really two questions. What happens when wind and solar are a lot cheaper than this process, okay? Including the storage, et cetera, down here under the rocks. Wind and solar are crashing in price. What happens when they're cheaper? What, we're just going to close up these biomass power stations that we paid $1 zillion to build? What happens when, this to me is even more serious, because this is on the near term. What happens when 90% or more of vehicles are electric vehicles and we're not using gas with ethanol in it? All this then is not needed anymore, okay? So they just close it up, I guess. Uncaptured CO2 comes out of these cars, some leaks out of these cracks in the rock or whatever. Some biomass to energy really isn't biomass to energy. Sometimes they suggest burning trash in addition to biomass. And we know that when you burn trash, all kinds of toxins are released because you got melted plastic and you got just a world of bad things when you burn trash. Okay, so that's what's going on. You use the crops or the trees that have taken energy out of the air, taken carbon dioxide out of the air, and you turn those into power. All right, now, first problem, BECCS is really inefficient. So here's a sort of diagram of, you start out with this much biomass, and there's carbon dioxide leaks out in all these different places: farming, processing, transport, the BECCS plant, okay? By the time you actually get electricity, you have only got 10.7% of the energy that was in the initial biomass. The rest of it has not been captured, up into the atmosphere. Biomass to fuel, again, losses. You get 26% of the energy in the original biomass converted to biofuels, okay? That seems really inefficient and can barely be called carbon capture, okay? Because you're losing most of the carbon. Also, and this is part of the story, only the emissions from the final product at the biomass plant are captured. The rest of it, these upstream sources, escape to the atmosphere. So Natural Resources Defense Council article had this quote, "The uncaptured emissions from BECCS are equal to about 80% of what comes out of a coal plant smokestack per megawatt hour." Wait, we're going to all this effort to get, a 20% improvement over coal? Doesn't make sense. Other problems: feedstocks require 25 to 80% of an area equal to 25 to 80% of current cropland, plus another billion additional acres, which comes from land converted from natural grassland and shrubland, semi-natural vegetation near ag and forest. Replacing natural habitats with biomass plantations just adds to our biodiversity crisis. Growing energy crops increases water and fertilizer use. 200 million acres of switchgrass requires as much water as all currently irrigated cropland and would use 20% of current global fertilizer use. So we're just making the water and fertilizer problem even worse. When you burn wood for energy, it causes an initial burst of emissions from burning the wood, right? And although if you replant, you accumulate that debt, you repay that carbon debt over time, it takes a long time. Here's a graph of how long it takes. Break-even time. When you burn the stuff, you get a big emissions of carbon dioxide. And then time, goes on. And if you have taken the biomass from marginal land, it takes 1 to 10 years to pay back that initial burst of emissions. Cropland, 8 to 28 years. Grassland, 28 to 31 years. Forest, 30 to 50 years. So it could be up to 50 years before we actually, sort of start having negative emissions, because we had this big burst of emissions from burning the initial biomass. So again, it doesn't make much sense to me. Now let's talk about the renewable fuel standard. Everybody knows about the fact that 10% or so of ethanol is added to gasoline, and this is mandated by the government to help the farmers. The renewable fuel standards, the guidelines are the renewable fuels must reduce vehicle emissions by 20% relative to regular 100% gas. However, a study last year of what went on in the early years of the renewable fuel standard, 2006 to 2008, and this was published over here is the link. It was published in Proceedings of the National Academy, found there were a bunch of problems, okay? First, the price of when the government started paying farmers to grow corn to make ethanol, the price of corn increased by 31%, and it dragged up the other price of other food by 20%. Corn acreage expanded by 6.9 million acres because all of a sudden farmers could make a lot of money growing corn. This caused a big loss of forest and natural habitat. Crop rotation declined. The way you're supposed to grow corn is to rotate it every year with soybeans or some other plant. Soybeans are a legume, they add nitrogen to the soil. Well, nobody wants to, forego a season of corn when they're making a bunch of money to turn it into ethanol. And so crop rotation declined in Iowa and surrounding states, which reduced soil health and increased erosion, okay? Synthetic nitrogen fertilizer use increased up to 8%, boosting nitrous oxide emissions. Water quality was damaged in the nearby areas, was damaged from increased nitrate, which is another byproduct of nitrogen fertilizer. And that leaches water soluble, so it leaches off into the water, phosphorus runoff, and more sediment coming from the increased erosion. And after all this, they find that in fact, the greenhouse gas emissions from ethanol are 24% higher than from just plain gasoline. This year, the amount of ethanol mandated, I think, went up a little bit, and it's still touted as a climate solution. It is not a climate solution, okay? It is making things worse. But the farmers in Archer, Daniels, Midland is making a ton of money. Anyway, farmers and big ag companies love the profits from ethanol. Ethanol companies say the incentives are essential to survival of the industry. Of course, that's a typical sort of explanation. They're planning 3 new carbon dioxide pipelines to take the carbon dioxide and stash it underground in Illinois and North Dakota, and they're being paid $8 billion for that from the of incentives from Ira and Bill. I defined this last time. 3,300 miles of pipelines. Now, this is interesting. I read this fascinating article from St. Louis Public Radio about the opposition to these pipelines. So many Iowans are fighting the pipelines, even some farmers. So one farmer, it was a fascinating article. He says, this is a quote from the article, says, this farmer says the ethanol market is fantastic for his corn. Well, of course, because he has a big market for the corn, he's being paid a lot of money, but he is staunchly opposed to a proposed carbon pipeline that would cut through his farm. So, hey, I'll take the money for the corn, for ethanol, but don't run that pipeline through my yard. Other citizens have a more reasonable explanation. They cite the Mississippi spill in 2020. All of a sudden, the Mississippi spill is getting a lot of press as people start to confront the idea of a pipeline. And there have been a ton of lawsuits and threats of declaring eminent domain, which means the government, the state can take the property because it's in the public good. It's likely that the companies are eventually going to get the land through seizures for eminent domain. This was in the Des Moines Register. It really made fascinating reading, and here are the links that you will get when you get the slides. Okay, that's BECCS. Lots of land, carbon capture partial, not really very effective. Direct air capture. This is something everybody loves because it's really technological, and people love technology. They love technological solutions because it's like, hey, this is going to, you have to be really smart to think this up. This is going to work. My opinion, totally magical thinking. Minimal capture, high cost, and all the problems of carbon capture and storage, all the storage problems. Here's the status of the leading companies, and this is from a World Research Institute. I forget, WRI, I forget what it stands for. I think it's World Research Institute, a big think tank that does studies everything. This is a status of the leading companies, and this is, I think, from last year. Okay, so there's 3 leading companies: Switzerland, Canada, United States. They have different, methods for doing it. They use different thermal energy source. You've got to have a source to actually, capture and run the thing and capture it. So in Switzerland, they are using non-fossil energy resources, geothermal, waste heat, et cetera. Climeworks, there should be an L here. There's a typo in their table. They're the ones who have the big direct air capture in Iceland, and they power that with geothermal, okay? However, they don't really have geothermal or those things anywhere else. So Carbon Engineering from Canada, who is going to build a bunch of plants in the US. Also, natural gas with carbon capture and storage, okay? United States, energy resource agnostic. In other words, they don't want to say, okay? Now, what projects are out there? 15 plants around Europe with a collective capacity of just under 6,000 tons of carbon dioxide a year. This is 400 tons each, okay? Pilot plant in Canada, they are developing a 1 million ton carbon dioxide per year capacity plant in the Southwest US. We're going to hear more about that in the next slide. Global thermostat, 2 operating, so these aren't operating, 2 operating plants in the US, which together capture 1,500 tons, 750 tons apiece. So around the world, there are 18 global plants, and they are capturing 8,000 tons per year. This is equal to the emission from 1,700 cars. And this is costing $250 to $650 a ton, okay? 8,000 tons to get rid of the emissions of 1,700 cars. If you electrified these cars, you could get rid of those emissions a lot cheaper. The largest plant currently available captures 4,000 tons a year. Yet these guys say they're building this 1 million ton capture plant, they're building it in Texas. Okay, if things work out well, the price might drop to $150 to $200. Again, I'll remind you, reforestation costs $50 a ton. The emissions from the power used in the capture, which is a lot of power, I think some of these plants have their own dedicated natural gas power plant to drive the fans that suck the carbon dioxide out. And so that reduces the net capture, but they don't ever confess that. Okay, more magical thinking. The US Department of Energy is building 4 direct air capture hubs, and they're giving the company $3.5 billion to build them. Each one is supposedly going to capture 1 million tons per year, which is a big feat since the largest existing plant captures 4,000. This is 1 million. 4,000 is what the biggest plant is now. This is the Iceland facility. Current cost is $250 to $650 per ton. So let's just imagine that we take $300 a ton and we capture 1 million tons a year. At $300 a ton, the annual carbon dioxide removal will cost $300 per ton times 1 million tons times 4 plants, $1.2 billion a year. That's a lot of money, especially after you spent $3.5 billion to make the plants. Now, I understand, new technologies need to have, research and time to be established, et cetera, but we don't have a lot of time, okay? If this takes 10 or 15 years to ramp up, it's not going to be helpful to us. And, it's really even worse than that, but so there was a fascinating editorial in Nature magazine, which is over here, the link is over here, where a scientist calculated that given that global emissions in 2022 were 40.5 billion tons, each year these 4 plants can set the atmosphere back, that is, suck enough carbon dioxide out of the atmosphere to sort of set the time back by 13 minutes. Meanwhile, another 40 billion tons is emitted. Okay. Even if we get emissions, this is without reducing emissions, even if we get emissions to 10% of the current 4.5 gigatons, we need 4,000 of these plants to reach net zero. Just, do the math and multiply and figure out how much that costs. Then the carbon dioxide still needs to be transported and stored underground. Here's where it really gets insane. Companies are making wild promises and they are buying carbon, removed carbon that hasn't been removed yet. Occidental Petroleum, this is a sort of rendering of their 500,000 ton plant that they are building, and they are going to use the CO2 to recover more oil. Occidental Petroleum, this is what they do, right? They are likely to be paid up to $85 per ton in incentives to take this carbon dioxide out of the air and then go, get more oil with it. And they are selling some of the carbon credits for offsets, okay? Several groups of companies are organizing, quote, advanced purchases. That is, there's not even a plant. They're already buying this removed carbon dioxide. And they're using that as offsets in their net zero pledges. So they have made a pledge to reach net zero by something. And they say, hey, we're going to use this captured CO2 to balance out some of our emissions. Microsoft, they say, last year, this is from one of their blogs, last year we made the world's largest purchase of carbon removal at 1.4 million metric tons. And this fiscal year, we are on track to exceed that by procuring 1.5 million metric tons, okay? 2.9, nearly 3 million metric tons. The global capture was what, 4,000 tons last year. Looking ahead, we will set even bolder carbon removal targets, and we will continue to increase our contracted volume year over year through 2030. That carbon is not being removed from the atmosphere. So it's just a big shell game. Okay. I don't want to get mad while we're going through this, but it does make me angry. Okay, Mark Jacobson, the guy who sort of has pushed wind, water, and solar for all the energy we need. He has a paper, and he points out that direct air capture powered by fossil gas has emissions from obtaining and burning, transporting and burning the methane that reduce the net captured CO2. In fact, here's a graph. This is emissions. Here's zero emissions. Here is positive emissions. This is stuff, this stuff obtaining, transporting, and burning methane. And this is negative emissions. And hey, the positive emissions pretty much cancel out the negative emissions. So direct air capture with fossil gas emits as much as it captures. Okay, well, what if you power the thing with wind? Well, then you capture some, but you don't emit any. But what if you just make power with wind on its own? Then negative emissions are even bigger. So Jacobson says, for the same energy cost, wind turbines and solar panels reduce much more CO2 while also reducing fossil air pollution and mining pipelines, refineries, gas stations, tanker trucks, oil tankers, coal trains, oil spills, oil fires, gas leaks, gas explosions, and international conflicts over energy. This is air capture. Increase these by increasing energy use, and they always increase the total social costs of pollution and water use relative to just using the renewables to eliminate fossil fuel and make the power directly. So I'm running out of time here, and I will just say a little bit about hydrogen. You'll have the slides, and I probably will have to talk about hydrogen and carbon offsets in another webinar, but I don't want to keep you guys too long. Hydrogen gas is two hydrogen atoms stuck together, bonded together. Hydrogen is a so-called energy carrier that releases only water when it's burned. So when you burn it, these come apart and you get the energy from the bond. It can be liquefied for transport or storage. First problem with hydrogen: you need to use electricity or fossil gas to make the hydrogen, okay? And that every time you convert between an energy source, you lose energy. So energy is lost. Liquefy or convert to ammonia to store or transport, energy loss. Convert back to electricity. By the time you do this, okay, you started with electricity, you do a bunch of stuff, bunch of conversion, you convert back, you only have 30% of the original energy. Okay? That does not seem very efficient. Gray and blue hydrogen are made from methane, and fossil gas is burned to make steam, and what happens is the steam, quote, reforms the methane, and the hydrogen atoms come off and form hydrogen gas plus carbon dioxide. No upstream emissions from the methane are captured as before. Blue hydrogen is just gray hydrogen plus carbon capture and storage. So still made with methane, but now it's stored instead of just going out into the atmosphere. Possibly useful would be green hydrogen, which is made with electricity from wind and solar, a different process. It's basically called electrolysis. It breaks the hydrogens off and you get hydrogen and oxygen. So there's a lot of conflicts about that. I'll just say here are things hydrogen could be used for. A few years ago, this is in a paper I read from 2020, people were advocating for a comprehensive hydrogen economy, but now that wind and solar are spreading so much, not so much. Hydrogen is not as useful as people thought. For heating buildings, not really. Electricity is cheaper and it's healthier because hydrogen, and it's mixed with natural gas or fossil gas, usually much healthier. Electricity is cheaper and healthier. Hydrogen is bad for your health. Cooking, ditto. Electricity is cheaper and healthier. Vehicles, electricity is 3 times cheaper than hydrogen. Heavy transport, which is now beginning to be done with electricity, and it's cheaper. Industry, electricity is already cheaper to make glass, paper, and aluminum. There may be some industry that, you can't use electricity. Electricity is cheaper for small planes already. Shipping might be a place where hydrogen is needed. Steel production, possibly, but there's a bunch of good new ideas coming down the pike. Ditto for cement production. These are usually cited as the sort of industries where you have to have something. But actually now people are coming up with good ideas to make green steel and green cement. The fossil fuel industry really wants to make hydrogen, but they want to do it on their terms. They want to keep making blue hydrogen out of methane and natural gas. And there's a big fracas about the incentives for green hydrogen from the Inflation Reduction Act. And it's a little technical, so I'm not going to go into it. You can read it on your own, and I'll send some references. But there's a big disinformation campaign from industry now underway. Here's the Baytown plant again, ExxonMobil Baytown complexes. Carbon capture and storage will reduce greenhouse gas from hydrogen by up to 30%. Oh, wait a minute. We need green hydrogen. Then you don't have any greenhouse gases. Disinformation from the industry about hydrogen tax credit. Next Era Energy and the Fuel Cell and Hydrogen Energy Association, which is a collective of fossil fuel organizations. They're saying basically, don't make this so difficult for us. Just let us do it in an easier way, which is going to cause more pollution to start out with, because otherwise a premature jump to hourly matching, which is what environmentalists want, will drive up costs, suppress production and jobs, and delay. This is the usual thing they say. It's going to cost jobs. Over here is another one. It's going to make factories close. It's going to forego the creation of 3.4 million high-paying jobs, concede hydrogen energy to China. These are the things that the companies always say when somebody pushes back on them and say, we need you to be cleaner. Okay, I'm ending. This is my recap. As I've gone through the past couple of weeks being angry, I realize and I remember that this is my favorite graph. Those of you who came to the first webinar have already seen this. This is the replacement of fossil fuels by the spread of clean energy. And we are about here in this plateau, which is filled with disruption, and it's bumpy, and it's kind of a stressful period because things aren't changing as fast as we want. We think something's going to happen and fossil fuels are going to go out, but right now the fossil fuel companies are fighting back. So I'm trying to understand in my own mind that we are in the middle of this bumpy and disruptive plateau where money is going to be wasted. Okay, billions of dollars is going to be wasted. We probably just have to accept that. The incumbents, that is the fossil fuel people, are going to fight, and promises they make will be unfulfilled. But in the end, it is not going to matter as long as if we are really past the tipping point for renewables. This process is inevitable. They are going to go down the cliff, and that's going to be it. It seems like this stressful thing is going to last forever. I can't promise it will end in time to really produce the future world we want. We can just hope the positives, the spread of wind and solar, et cetera, outweigh the negatives that are going to come our way from all this wasted money and unfulfilled promises. Okay, my take. Relying on the lure of these expensive technologies is irresponsible. It's not going to solve the climate crisis. Fossil fuel companies need to be reined in and their disinformation revealed. We need to remove the subsidies. If their efforts in carbon capture and storage fail, as so many before have, cut off their incentives, allow only green hydrogen production, and restrict the use to sectors that can't be electrified. Federal energy funds for climate action should prioritize increasing renewables, solving the transmission issues as part of that, increasing energy efficiency to reduce demand, and fostering recycling and virtual power plants, which I talked about in the last webinar, improving efficiency and electrification in low-income and environmental justice communities so that they can not spend such a large fraction of their incomes on power. What can we do in this landscape? Well, we can discover for ourselves the disinformation and the lies, and we can educate other people and be a source for our community of science-based information about why we need to reduce emissions and not rely on these technologies, and information about climate actions we can do at home and in our communities and the impact they can have. I talk to you, you talk to your neighbors, they talk to their neighbors. And my goal is to provide you with an entree to the information that you need to speak authoritatively to other people about real solutions and fake solutions, okay? Show how to make the sort of renewable spread, electrification, show how to make the good things happen by doing it yourself with your own actions. Reduce your own energy use, electrify your own home. Be a model for civic mindedness. An example, explain to people why sometimes it's important to allow transmission lines or infrastructure or whatever, solar farm in your county, in your neighborhood, whatever, because we need this stuff. We can't all, put it somewhere else. Advocate in your local community and with your state and federal lawmakers for renewable energy and electrification. Here's the HOCO climate action people, Howard County Climate Action, which I've already showed you at right before they go into the county council to argue about electrification. And how about making, creating the kinds of things we want for the future, like walking and bike paths, et cetera. Finally, find your people, find a group of people you can talk to, who can support you, who can say, okay, I know you're angry, but here's what we can do with that anger. Support each other, use your collective voice, and vote. I'm over time.